Dear viewers and subscribers, welcome again to our YouTube channel Max the Service. Please subscribe and press the bell icon to receive all notifications regarding any video we are uploading on this channel.
Dear viewers and subscriber, thanks again to watch our YouTube channel Max the Service. Max Service is the only YouTube channel to take care of providing videos with proper information like documentation, architecture discussions, and working with practical examples for beginners and expert to learn by watching videos on Max the Service YouTube channel and start leading in the industry.
Okay guys, in last session we briefly discussed Docker outline and today we will start our second session on Docker and we will be discussing in this session introduction and under introduction we will discuss all these topics: what is Docker, why it is popular, why when to use Docker, traditional and new approaches to use Docker, importance of Dockers, benefits, alternative, and all use cases apart from feature, advantages and disadvantages of Docker. So let's start first with introduction and let's see what is Docker. Okay, Docker is open source containerization platform by which you can pack your application and all its dependencies into a standardized unit called a container. Containers are lightweight, which makes them portable and they are isolated from the underlying infrastructure and from each other container. You can run the Docker image as a Docker container in any machine where Docker is installed without depending on the operating system. So guys, here we have number of things. What first is containerization, and second is uh, lightweight and portable, and third is image, okay, and fourth is depending on operating system, installed without depending on operating system. So let me describe one by one with some graphical presentation. In this image, it is simple and easy to understand. In left side from dev, you can see that any development team and operation we have get developed and it is become an application with different languages, database, node server, Ruby, Java, whatever language you have used. All those dependencies and libraries, after developing, testing, now it is available as a standalone app which can be deployed, which can be installed on anywhere to run. The containerization term used in this video, actually when you think that okay, there is number of things related to each other and we don't want to uh, do the things again and again. Let's suppose you are working on Windows and then you are going to start running your application on Linux, then definitely you have to download all the dependencies, you have to check your integrations, you have to install database, and you have to check also database configuration and connection with your application. But once you do your that application as a container, then those container can be portable, those container can be duplicate, and those container can be uh, run anywhere. So in the right side you can see it can be run on Windows or Linux or anywhere in cloud, in your on premises, and it can be connected with any other application. Here the question is how this application becomes as a container, run as a container. Actually there is a file, Docker file you used in your application, where you do some configuration, do some settings, and then you run some commands to build that application as an image. That is called Docker image. Once your application is available as an image, and then when you start running your image, it runs and available as a container. So you can also move that image anywhere to start as a container. So it is very simple. So let's see another aspect why Docker is popular. To measure its popularity, here are few things to consider. One is portability. What does it mean? Once you have image, you can move anywhere and run as a container. Reproducibility. Once you packaged all dependency as a image, it will remain consistent across all the environments. Even you are in QA, dev or production, you don't need to do extra thing. You don't need to do download, add, integrate anything what you already have done. So reproducibility is zero. Efficiency, you can run multiple application on a single host system. So in any requirement to make different application, more than one application, you can just multiple instance, you can run multiple instances at the same time. And scalability, on the base of your need, if you can increase and decrease your images and run as a container, so it's a very good benefit. Okay guys, if we discuss the approaches of development and deployment of application, so there are three different ways. In start, we just use only one operating system to deploy a whole application, right? Then the concept become of virtual machines, where we virtualize our operating system. We can create guest operating system, like here in left image you can see guest OS, guest OS, guest OS. Now we have one operating system, one machine, and we divided that one machine into three guest operating systems. Okay. So for that, to deploy number of application to avoid conflict between these, we must virtualize our operating system, and now we have virtually three operating system to run the application A, application A, and application B. But when we come with the approach of Docker and containerization approach, here in right image you can see that there is only one container in a engine, and then you can share your binaries, your libraries, your dependencies with more than one application. Let's say you can see here we have two application running A, but with same libraries and dependencies. Why? Because we containerized, we build an image, and now we can use multiple instances, and we don't need to virtualize operating system, we don't need to make configuration, setup and download and install everything for each application. Just we can start with already built image, and we can run as a container more than one application. So this is the major benefit and uh, tradition of enhancement in development and deployment of application. Guys, here are alternatives of Docker. We will also do some sessions on all of these after Docker. So here is Podman, RKT, Linux container, and uh, another is containerd. So we will discuss later on it. So here you can go through its definition, and we will also discuss in detail why we can go other than Docker to choose any one of these options. Guys, whenever we choose any tools and technology, definitely we have to go through the requirement and we have to understand the use case, whatever we are going to achieve or implement according to our business case. So Docker, first important use case to use Docker is to go with the CI/CD pipeline, where you need continuous integration and continuous deployment. Here is just you have to configure a file with some settings and instruction, and where you will be automatically build image, and it will be image will be run as a container on the set environment, either is it a QA testing or development, either production. So another important use case is microservice architecture, because when we go with microservice architecture, definitely we have to scale up and scale down. You have to utilize a number of instances. You have to implement some securities. You have to go with the integration and communication between instances. So all of these achievement can be easily done when you go with Docker and containerization. Okay, the third important use case is to go with the development environment consistency. Okay, it is third and important. Another use case, it will ensure with consistent deployment, testing, and production environment. It actually reduce the works on my machine issues. Okay, actually, when all of this can be done with GitHub Action, GitLab, or there are a number of technologies available. So last use case is also important, which is multi-cloud and hybrid cloud deployments. Okay, sometimes you also need some uh, different deployment, different cloud, like you may have hybrid environment, you have pure cloud environment, you might be deploying running images as a container on your on premises and some of on cloud. So all of these concerns are covered when you go with Docker. Okay guys, let's discuss some features of Docker, which is one of the important is open source platform. Open source platform is a very good feature where you can integrate, you can go with different technologies, tools and technology you can use. So it is very good benefit. Another is easy, lightweight, and consistent way of delivery of application. These features allow us to we have studied and we have seen in previous discussion that it is portable, and we can have consistency within the libraries and dependency within the same image, and we can move from we can run in any environment, we can move from one environment to another, we can also move from one operating system to other. So fast and efficient development life cycle. It is fast and efficient because once we have configure your Docker file, then you can do your development fast. You don't need to integrate, don't need to download, and you don't need to every time whatever your application need all those tools and technologies every time. So segregation of duties mean this reduces the possibility of work in the development, but now an operations issue. Service oriented architecture. Docker also supports service oriented and microservice architecture. Docker suggests that each container runs only one application or process. This encourages to use of the distributed application model, in which an application or service is represented by a collection of interconnected containers. This greatly simplifies the distribution, scaling, debugging, and inspection of your application. Security. Security management feature of Docker saves secrets into the swarm itself. Docker containers provide a high level of isolation between different applications, preventing them from interacting with or affecting each other. This makes them a secure and stable platform for running multiple applications on a single host. Scalability. The platform is easily scalable as Docker containers are lightweight. The portability of Docker also makes it simple and dynamically manage workloads. Scaling up or down apps and services are business demand in near real time. Docker provides a simple and intuitive command line interface that make it easy to create, manage and deploy containers. Reduction in size. Docker offers a great degree of capacity to minimize development size. The rationale for this is that it may deliver a reduced operating system footprint via containers. Next is image management. Docker uses images to store the necessary files and dependencies needed to run applications. These images are created using a Dockerfile, which is a set of instructions that tells Docker how to build the image. Developers can use these images to create new containers or update existing ones. Docker also has a registry called Docker Hub, which is central repository for storing and sharing images. Second last is networking. Docker allows developers to easily connect containers and services using its built-in networking capabilities. It supports the creation of virtual networks and allow developers to specify which container can communicate with each other. Ooh, great. This makes it easy to set up and manage complex microservices architecture. Last feature is volume management, which is very important to go through and understand. Docker provides a volume management system that allows developers to persist data generated by containers. This is useful for applications that require a database or other data storage. Docker volumes are stored on the host system and can be shared between containers. So guys, we will go all these with all these features practically. What we have theoretically we have discussed in this session, I assure you I will prove, I will go with some example and everything we will be doing practically so that you will realize whatever is on the Docker documentation, we can go through and we can do some practice and we can understand with some practical example. Guys, let's start with Docker architecture, and everybody know that Docker makes use of client server architecture. The Docker client talks with the Docker daemon, which help in building, running and distributing the Docker containers. So Docker client runs with the daemon on the same system, or we can connect the Docker client with the Docker daemon remotely as well. With the rest of, we can also use REST API over a Unix socket or a network. So the Docker client and daemon interact with each other. So to start with the Docker architecture, we will be discussing one by one. Here you can see we have first client, then we have Docker host, and we have registry. These are the main uh, parts of Docker architecture. So we will be discussing one by one. So first we need to discuss what is Docker client. Okay. Actually, with the help of Docker client, Docker users can interact with the Docker itself, Docker host. Mm, the Docker command uses a Docker API. The Docker client can communicate with multiple daemons. Let's suppose there are one we have remote API, one we have a CLI, or one we have desktop Docker desktop. Then every client will create its own daemon thread and will start communicating. Okay, when the Docker client run any Docker daemon on the Docker terminal, okay, then the terminal sends instruction. Okay, send instruction to Docker daemon. Okay, the Docker daemon gets these instructions from the Docker client with inside the shape of the command and REST API request. Okay. So furthermore, Docker daemon work as per instruction or commands run from command client from CLI or remote API or even Docker desktop, whatever what client we are using. So the main objective of Docker client, okay, to provide the way direct pull images from the Docker registry. Guys, this is very important to understand. Within the Docker client, you can directly ask Docker daemon, okay, let me download uh, any image already provided on the Docker hub. Actually, Docker registry also called Docker hub. Instead of I go for building and executing another command to build an image, and then I can run that image as a container. So because on Docker hub on registry there is already image available, so let me pull and execute as a container. Let's suppose I'm running my application, and instead of downloading and making an image of Redis, then I can directly execute command and ask Docker daemon to please let me pull the Redis and then start as a container. Okay, here you can see a request made to this SQL. Okay, and then here is it is downloaded as image, and here you can see it is running as a container. Okay, so three steps. One is running command. Okay, to pull, then this uh, SQL database will be downloaded as an image. So step two, and then you can run this image as a container. Here is step three. It is simple. So it is the basic purpose of Docker client. Okay, then we have Docker daemon. Okay, what is the purpose of Docker daemon? Docker daemon manages all the services by communicating with other daemons. Okay, let's suppose we can ask Docker daemon to pull the image, to run the image, to execute the commands in the Docker file, whatever configuration we have provided in the Docker file, which is built in the image. Actually, all the commands provided in Dockerfile executes and image accordingly run as and available as a container. Okay. So it manages, actually Docker daemon manages objects such as images, okay, containers, okay, networks. Networks mean if you want to communicate between these containers, if you want to communicate this container with outside of another host, if there is another host, okay, okay, okay. So if there is another host and another container is running, so then uh, networks object will help us to interact with we can set some IP configuration, blacklisting, whitelisting, and port open available to interact with other container within another host. This host might be running another operating system, might be remote, or might be on cloud. So Then if this host is on premises and another is on cloud, so your network will become work as a hybrid. So then other is itself, what is Docker host? Okay, this part is Docker host. A Docker host is a type of machine. It might be operating system where Docker, when we install and run Docker engine, it becomes a host. Actually, we virtually distribute our operating system. We can run Docker engine and then we can further virtualize it. We have covered in previous session this concept, which is virtualization and difference between virtual machine and containerization. Okay, so all the Docker images, uh, first let me finish this Docker host. Okay, a Docker is a type of machine that is responsible for running more than one container. Here you can see we have more than one container running within a host. It comprises the Docker daemon. Yes, it includes Docker daemon, images, yes, containers, networks, and storage. Simple. Another one is Docker registry. Okay, this one is Docker registry. We can also call, we can say Docker hub as well. All the Docker images are stored in the Docker registry. You can park your images in Docker hub or Docker registry in private manners, but it is publicly available to everyone. Whatever the images provided by Docker available, you can download and start working with those. Okay. So when we can run our private registry also with the help of Docker run or Docker pull commands, we can pull the required images from configured registry. Images are pushed into the configured registry with the help of Docker push command. You can also build and then you can also push your images on. Here you can see the arrow blue. You build first, then you push this image which is here to here. You build application image, then you push it into Docker host, and you when you run command Docker push and Docker daemon responsibly to work accordingly and push this image placed on Docker host on registry, so that you can download later on. You can also save your number of images with versioning, so later on you can utilize, you can also save as a backup. So if we dig into more detail, then we also have Docker objects. Whenever we are using Docker, we are creating and using images, containers, volume, network, and other objects. Now we are going to discuss Docker objects. So what is Docker images? And images contain instruction. Okay, here is the file which contains instruction of an image. Okay, and it is just read only template. Actually, when you write instruction in Dockerfile, it becomes a template where image can read and work accordingly. It is used to store and ship applications. Images are an important part of Docker experience as they enable collaboration between developers in any way which is not possible earlier. You can directly communicate and configure your images and instead of building and then deploying. Okay, Docker containers. Docker containers are created from Docker images we have discussed, as they are ready application. With the help of Docker API, CLI, we can start, stop, delete, and move containers. Okay, directly, if you have your image placed in the host, you can also directly execute command to delete or stop whatever action you can perform with the container, so that later on you can also, instead of deleting image, okay, you can also delete container, and you can again build container from the image also available on host or on registry. So what is Docker storage? uh, Docker storage actually is the same as, let me show you. Yeah, here is your container, and there is different type of storage, like data volume, volume container, directory mounts, storage plugins. Okay, you can also refer with the storage plugin. You can also store your data from the container externally, and you can also specify, you can also mount your file system. Okay, once container deleted, I can store the data reproduced by container within a file, so another container can share these information as well. And also we can also use Docker area, where we can share between different containers as well. So then we have Docker networking. Okay, it is simple. Also, we have different type of Docker networks. One is bridge. Actually, it enables. It is default network. We can use this when different containers communicate with same Docker host. Now, let's suppose we have two containers here. One is this, and second is this. It's a database container and it's a Redis container. If we we can, if we want to make the communication between these two containers, then we will be using bridge network type. So second is host. When you don't need to, when you we don't need any isolation between the container and host, then it is used. Actually, I don't want to isolate this container, so that another from the host, nobody can interact with it. It will be running standalone. So I will use host network type. So third is overlay. For communication with each other, it will enable Swan server. Here you can see it is overlay. If your containers are in different host, then to make the communication, you will be setting overlay network type. You can also disable by setting property to none, and you can also use MAC VLAN. This network assigns MAC address to containers which look like physical address. Okay, so guys, for today it was great discussion with the architecture and its component, how the architecture works, and how the things when a developer do with the architecture, how the things works. Okay, so I have explained you very clearly. You are allowed to please set comments for me if I am missing, I am not delivering as expected, then I can improve myself, so that you can avail more knowledge regarding any session, any technology or video. Start with Docker installation on Windows and Docker installation on Linux. So last session was about Docker architecture. We have explained how the Docker architecture and its components, how the things works. So today we will start working with installation. So here in this image, you can see clearly that when we start installation of Docker on Windows, you can see uh, the main thing is to understand this. Let us look at the left side of the below image, where you can see on Linux operating system, Docker is installed directly on the operating system. But if you look at the right side, On Windows operating system, Docker is installed inside a Linux virtual machine, and we use a Docker client to interact with Docker, right? In this case, here you can see here we have simple steps to install Docker on Windows. Prerequisites you must have at least nowadays, guys, we have at least Windows 10. But if you have lower than 10, even 7 or higher, it will work. Operating system must be 64-bit. Then you have to download and install Linux kernel package. Okay, now what is the next step? Visit the website and click on Docker Desktop Windows button. Okay, and here you will find install Docker Desktop on Windows. Then you can start downloading for Windows here, and then the second step, the install will ask to install VSL2. Okay, it is Windows subsystem for Linux. Then you need to click on it, and this will download install Windows subscription for Linux to for your as shown below. And then you have to go step number 3. Then you will need to restart the system, click lock and restart button, and Docker installation to start. Okay, after that restart your computer, it will open up the Docker windows as well. Here you can see. Then you can simply go and check Docker version. Okay, so it is very simple to install Docker on the Windows. Let me open CMD, and let me increase the size so that it is visible even on mobile. Okay, because I already have installed Docker, and if I run the command Docker version, here you can see. I can also show you the Docker desktop Docker. Actually, on Windows, it is highly recommended because you have graphical user interface where you can view your images, where you can also download, pull, push, whatever. Here you can go and see what are the images are available here. You can also see containers. Here I have running image as a container. So we will also cover this. We can also use this one integrated with the OpenWS, oh sorry, VS Code. So VS Code, it is integrated with this Docker desktop, with more helpful to work with the Docker environment. So this is very simple for Windows, and let's start how it works on Linux. To start Docker on Ubuntu, so let's start first rephrase what is Docker. Actually, Docker is powerful tool for developers, system administrators, or any DevOps engineer. It made it easier to deploy your application without any hassle of using its containers. Docker containers are lightweight. Why these are lightweight? Actually, it does not require to you to install or dependencies in your servers. That's why it's lightweight, and we can handle an application with its all dependencies, ensuring it runs smoothly across different environments. So in this video, I will show you how to install and set up Docker on your Ubuntu. So prerequisites are your server operating system should be updated, and you must have sudo privileges, because Docker daemon work with sudo privileges. Other user which don't have sudo privileges cannot interact with Docker daemon. It's mean from CLI, from Docker desktop, it will not be able to execute the commands. So we will also need to ensure first either system is let me change the cursor size. uh, yeah, yeah. Okay, so first of all I will go to just check sudo apt and update. Okay, done. And then we also can check upgrade as well. Okay, great. So let me clear it. And now first step is to install Docker. We will use Docker official repository to ensure that we are getting latest version. And also, let me show you first on installing the older version. First, we will check either we have already installed Docker or not. The command is Docker version. Yes, we don't have, and we can also um, check the below command. If you have already have Docker, then here is below command to just run install, sorry, apt update sudo apt update and sudo apt upgrade. These are the commands we have executed to just make sure that we don't have any older version, right? Okay, now everything is up to date, and now let's start with first step to make the installation of Docker. Here you will use sudo apt install apt transport https and ca certificates curl software software proper properties common, right? Yes. Okay, now next to add Docker's officially GPG key, which command is curl fssl https download docker.com linux ubuntu gpg sudo gpg minus o, where we want to use this repository, our key user share key rings doc. Here we need to specify Docker archive keyring dot gpg. Okay, so after this then add the Docker's apt repository, right? First let me clear it. Okay, first command to update installation on Linux, which is just you can run sudo apt get update. Then you need to run sudo apt get install -y docker.io. Okay guys, we have installed Docker. Let me clear and check if we have Docker version. Yes, here is the latest version. We have Docker installed. Next command is to start the Docker. Okay. We can also check either Docker is running or not with the command. Like let me check how we can do this. If I just run the command docker, sorry, run hello world, unable to find image hello world locally. Okay, so the response from daemon pull access denied from hello world repository does not exist or may require docker login. So denied, request access to resource is denied. So let me first run the docker. Okay, with sudo privileges, sudo systemctl start docker, and I would like also run the command enable. What this command do, actually this command enable the docker whenever you restart your machine, your server, docker automatically will be started. Now if I check again the version, okay, fine. So now I will just check either my user is able to run the docker or not. If I run the command again, docker run hello world. So docker is running and looking for here you can, I can explain you guys. Actually docker started and tried to find hello world locally, where as in the last session, let me show you. Here you can see, actually when I run the pull docker run command, it goes to docker daemon and okay and start running the image, because here we don't have any image to start running docker. So what should we do? Now we should just do few changes, and I just download new. Okay, then because here it could not find image, and then it started to download from registry from docker hub, and then what it is done for us, hello from docker. This message showed that your installation appears to be working correctly. To generate this message, Docker took the following steps. Docker client contacted Docker daemon. Okay, this Docker contacted Docker daemon. Docker daemon pulled the hello world image from the Docker hub. It pulled the image from Docker registry from hub. It downloaded from the hub, and in on the host, the Docker daemon created a new container from that image which run the executable that produces the output you are currently reading. Actually, whatever we are reading, it is written in the config file, Docker file, in hello world image. So it is saying that after downloading, pulling on the host, and it executed the image as a container. And then Docker daemon streamed that output to the Docker client, which sent it to your terminal. So this hello world, hello from Docker, it is sent back to from here to our terminal. So this is the actual workflow when we run any image, because when I run hello world, uh, it started to look into the local host, because in localhost it was not exist. Then it started to download and executed that image for us, and produces the result. Try to something more ambitious. You can run Ubuntu container with the Docker run. So it is saying that you can also run Ubuntu, another image, share images, automate workflow, whatever. For the rest stuff, definitely we will be doing a lot of. So just I showed you the architecture and how it works with this command. We will be working like this. I will showing you how the things are going, how the things are working from the architecture point of view, the flow of how the flow is going to be happen. So now let me show you another thing, because as you have seen, I have logged in with root user. If I logged in with another than root user, Docker will not work, because Docker daemon work only with root user. So now uh, to add some other users, let me show you the command. Let's suppose you are an administrator and you have root privileges, and you also know the other users in your team, in your organization, which only you want to work with the Docker, to run images, to run image as a container, everything. So then what you need to do, you just because right now I am administrator with root privileges, and just I will add, run a command, user mode dash -ag docker, and here I will add username, whatever the user is, I will add here. Okay, user. Let's suppose my username is Shahid, then I will add here Shahid. So when Shahid will log in to this system, okay, then it will be Shahid will be able to work with Docker as a root user. So let me show you one thing more. The path of Docker daemon. Okay, cd etc etc docker, and here you can see no directory, ls. How we can see the file? Just let me know. Diamond. Vim daiemen.json. Okay, so JSON is empty. We don't have any JSON file available. So I will just add quit back. Okay, so other thing which should I, after doing any changes in daemon on JSON, you just need to restart your Docker. To restart your Docker, what command we should use? Sudo systemctl restart Docker. Sorry, it will restart your Docker. Okay, then you can also again run docker run hello world to check that you have proper access. So I also help you to how you can just enable your docker. You can check the status of your docker. Sudo after restart you can check your status of your docker. Sudo systemctl ctl status docker. Mhm. Sorry, systemctl. Here you can see active and running. Okay. So what else I can help you uh, to? You can also check with the Docker PS. It will show you if you already running any container images whatever is. Okay, and you can also stop as we have running our image because we have restarted our Docker, and then if I again run hello world, it will run. Okay, and now if I execute PS, okay, there is no PS. Yeah, here you can see with the a command it is showing me because I have executed two times hello world, so there are two images running. Amazing Backwell, it is a default name, so I can also stop using Docker stop the container ID. What container ID we have here is, okay, if I again go with a, now you can see I have only one. Clear. And if I again stop, if I want to remove, then what command should I use? Docker rm container id. Okay, now you can see I have only one. If I again if I stop this, it will only stop, but it will show us the container is available. And if I just remove, now you will not be able to see any container available. Here you can see. This was very basic things about installation of Docker on the Ubuntu Linux operating system, and I just executed few commands basic just to make the things verify okay everything is working, how the image is pulling from registry host and into the local machine, and then how the images get into convert to container and start running. Please subscribe my channel if you are not. Also press the bell icon. You will be receiving further notification of all the videos. And one assignment I am assigning you. Once you install Docker on your Windows operating system, then you have to check the command docker run hello world and see how it works. Proper working with Docker, where we will be using Docker desktop and VS Code, and we will be using CLI commands. We will be using Docker files to build image and start that image as a container. We will be using Docker Hub and Docker itself GitHub, where we will be pushing our image on Docker registry and GitHub. So let's start. Okay guys, let's start Dockerize an application. We are using Spring Boot and Java based application. Let's start how to Dockerize and manage through Docker desktop and VS Code. First of all, I have to start it with VS Code. Okay, so we are using same application, cmd code dot. So we will be using same application as I already explained you throughout the series of Dockerization, Docker and DevOps, so that we will be sync whatever changes we are going to do. And so guys, this is available publicly on GitHub. You can clone and you can do some more testing, and you can also commit with your message. I will review and approve or whatever. You just make sure that you go through the our series of GitHub, where we have covered branching, merging, git stash, all the commands for cloning and everything. So you can watch those videos for to get hands on Git and GitHub. And you can also use my repository. It is available publicly. You can download and work with that, and you can put your comment if you have any issues. So to dockerize any application, there are number of options. So first option is Dockerfile. Simple. So I will create one Docker file. Okay, and I will add basic configuration, like it's as it is a Java based application. So first of all, I have to use from the JDK. Open JDK, and it is 17. Okay, and I will add jar file to with different name, like add my source is target demo dash 0.0.1, and it is a dash snapshot dot jar, and destination I want be our demo dot jar. Okay, so it is the file. Here you can see, you can whatever your application built, you can just mention here. So it first it will go and see if in the target folder if there is demo.jar, it will convert into demo.jar, simple demo. It will remove this snapshot, whatever is, whatever name you can mention here. And then we must have entry point like Java and minus jar demo dot jar. Okay, so these are the entry point of like Java, and we will be having demo dot jar. So we will be cover in another video of what are the configuration parameters of Docker files we can use. We will be having another video. So today we'll just going to Dockerize an Spring Boot application. Okay, now we have two options. We can utilize this Docker file with some POM configuration to build an image, and we can also use a command like Docker. First I have to check either I have which version I have. Docker Okay, it's our latest version, and now I will use Docker build. uh, Now it's a name I want to use, and it is demo, then which version, latest, in current directory. Failed to solve, Docker file cannot be empty. Okay, I did not save, I guess. And now let me rerun. Okay, so how I can check either I have Docker image or not? Just I have command Docker images. Sorry, Docker images. Here you can see we have demo just 15 seconds ago. Now we can also view this image on Docker desktop and on VS Code. To view this image on VS Code, I can first you have to go through and add Docker plugins, and let me check if I have. Yes, I have already. And I can also manage all the images and container from VS Code. Just I have to connect with the Docker Hub. I have to provide my name and password. Okay. Now here I can see whatever in my repository name is Shahid Hussain Abbasi. I already have two application pushed on Docker Hub, because when I will be log into Docker Hub, I can view these application. So right now you can see here we have image demo, right? Created 2 minutes ago, and same I can also view on the Docker Hub. So Docker Hub, let me log in and get into that. Okay, I'm also logged in, already logged in to Docker Hub. Okay, and now I have to uh, check either I have or not. Okay, Docker Home, and here I will launch Docker Desktop. I have already installed. Yeah, here you can see, and here is image with name demo. Okay, 2 minutes ago we have created. Now we have two options to run this image with the CLI command prompt, and also we can run this image from here. If I will just run from here, it will start running as a demo application. Okay, now here is logs. I can see what all the containers log. I can also inspect whatever the configuration I have used, and I can also have CLI here as well, and I can also use statistics, how much memory, how much processor, everything is being used by this containers. So guys, this is default name created by Docker Hub. We can also name the container when we start image as a container. Okay, so first let me check either we can uh, log in, and so it is running on HTTP port 8080. Just I will, and localhost 8080, sorry, 8080. Okay guys, here you can see we have a hello demo, right? Now let me run. this as a container docker run. I'm going to provide port 8080 and 8080 demo. Actually this is the name of image, and it is the port what we exposed, where I mean from container we can access this application with 8080, and it's a port of application internal, uh, internal in Docker. Now it is running on 8080, and let's see either we are able to access or not. Okay guys, here you can see we have a hello demo, right? And just to make sure either we are accessing the right one, let me provide the argument here, as it is request parameter name. If we don't provide name, it will print demo. Otherwise, if we provide the name, then it will also display the that relevant. Yeah, name maxi service. Here is maxi service. Whatever we will be providing, it will be uh, in response will be receiving this one. So guys, here you can also see in VS Code we have this image, and this one is container. You can also see containers, you can also see all the images and all the images on GitHub. So this can be seen on Docker desktop, because we did not run that image from here, so we run this image from VS Code. Now it should be available here as well. Here you can see. Now it will be showing the port what we provided in CLI. So this is very simple guys. We can also uh, we can use Docker desktop, and we can also use the VS Code. Let me sign in with GitHub. Yeah, actually we were already signed in, so just it is about to sign it again. Okay guys, so now what the things we left, just we can push this image to on both side, on GitHub and on Docker Hub. So first let me show you how we can push this image on Docker Hub through VS Code. Here is the way. Just you can right click and push Docker Hub. Yes, here is, just enter. It will be available on Docker Hub after successfully push to, yeah, pushing. So in the meantime, we can also push our new changes what we have Dockerized our application on the GitHub. So let me open another CMD, git status. Here you can see we have changes in 3 files, in POM, in application demo application, and application.properties. So, and also we have created Dockerfile. So first of all, I will use git add dot. Okay, then I will use git status. Now everything is available to push. And now I will use git commit message dockerization the spring sorry added docker file to run application as a container. Git status. Now just we need to git push. Now let me check. I was in master branch, so this is actually mistake. We should change our new branch and then we merge these changes. So right now, just to save the time, I did like this. And now I will be going to GitHub and see either this change is available or not. Okay. So it is in progress, pushing this image to Docker Hub, and now I will be going to I will log in to GitHub. Yeah, here already I have logged in. No, GitHub. Okay, so I will be checking for demo. Here you can see added Dockerfile to run application as a container 1 minute ago. So we also got the changes here as well. Okay. So guys, in this session we have covered how to use VS Code and Docker Desktop to work with Docker, and we have Dockerized our first application. Okay, to start with second method, how we can use Dockerfile just instead of creating image with CLI command. Just we need to do few changes. Let me show you. Here I have plugins which I have to provide. Okay, these are the Maven plugins. It will actually read the image file. It is a prefix name we are using here. Okay, and here is the artifact ID what we are using, right? This is the first change, and second is just to add properties. Okay, here is the prefix Spring Boot, Docker. We can use whatever we can use also max the service. Okay, port is 8080 base directory, and here is the version of Docker file, and here is the plugin we will be using. So simple, what we will be using. Simple, we will be using command like we have instead of creating image, we simply can write mvn clean install Dockerfile build. These plugins will automatically pick the jar file and start building image. Here you can see image will be built under max the service demo latest. We can also ignore this one, and whatever name we can also put here. So after building this image, we will be having two images. First is demo itself, and second it will be available under maxi service demo, right? This one is unwrap of what we have pushed actually. And also we can see this image here as well. on Docker. You can see here is another one, just we are going to push. So it is creating OpenJDK, which is already exist. Okay, great. Now we will be having, it is container already we have. Okay, and here must be more than one image. Yes, here is another one, and then this image we already pushed. So now we need to run this as a container. So the command we have, let me run it again. Docker, as we already running container 8080, so we'll be using another port, right? Docker run port 8081, internal port is 8080, and demo. We can also use container name is demo container. Okay, okay, so it is also running. Here you can see you have demo container up, and it is also available in containers. Here is demo containers. This was name already given by Docker Hub, and this is the name we provided. This one already we are running, and second container we have to check with 8081. Okay, so now we have running two containers. The only change what we have, only just to add plugins and save the time for running creating images, and just read configuration from image and then start building image. Okay, and now we can also see Docker images here. Here is under max the service demo, and here is demo. Once you will push this one, it will also be available here, but we don't need to do this as we have already this one, and just it was the way how we can also build image with the Dockerfile. Okay guys, thank you. So next session will be more with some more practice. We will explore Docker desktop and a lot of things. So please remember how to connect this Docker hub with the VS Code, and how we can manage containers. We can run, stop, start images, containers, and here if I delete container, then definitely images will be remain there. We can also again start this container as well. So here you can see in second method we already have OpenJDK from GitHub, downloaded from GitHub, but in this image we already using built-in. So we'll explore more in detail. So be connected, please subscribe if you have not, and also press the bell icon with all options, so you will be receiving all the notification. Thank you. Recap the concepts of Docker. What is container? What is an image? What is registry? What is the Docker compose? Let's start with what is Docker container. So let's start with the discussion of Docker concept. So first concept, why Docker container came into existence, what the revolution in development and deployments come with the Docker concepts. So today we will be discussing how and why we need containerization, right? So to start with, let's suppose we have been asked to develop a full stack application where we need front end like Angular or React with the backend APIs like we can use Spring Framework or .NET, and also we will be needing our relational database, which is MySQL. So let's suppose we are going to develop a killer application or killer web app, or we are going to develop a full stack user management system, whatever is. It should be contains all front end, back end, and database. And the same time, we need developer to start on the same application so that we can get develop things fast and in a better way. So another developer start working with the Angular, and let's suppose Spring and MySQL. Okay, they started development, but they forget to sync with the versions. Like developer 1 started with the Angular 8 and Spring Boot 2.3.6 and MySQL 8.0.1, and the other developers start working with the Angular 12 and Spring Boot 2 and the uh, MySQL with version 5.0.1. So they have started and they are ready to deliver their application. So what is challenge here? Here, when we ask them, okay, please merge your code and give their application for quality assurance testing or for UAT, whatever next process in SOP. Okay, so what is the next challenge? Let me share in other slide. Okay, now application is ready and developer 1 merge into repository and also developer 2 merge into the same repository. They merge their code so that application can be merged and deployed. So you can see we have development environment, staging, and production environment. Here we also have some installation of Java, JDK, Java, Spring Boot libraries, Angular, MySQL. We have to take care of the version, what version developer 1 has been started with, developer 2 must be start with those. Let's suppose they have merged the code and there is no any further testing, and they started deploying their application on any environment, development, staging, or production. First, definitely they will deploy on the development environment so that unit testing can be performed. But guys, you can see here we have Angular 8. Okay, it is good that we have almost the similar version of Angular 8, and we have Spring Boot 3.5, but here developer 1 have 2.3 and MySQL 2.0, and here is also 2.0. Okay, but here conflicting with Spring Boot version, and also we have let's see the code of developer 2, it is also merged, and there is also variation with the version of uh, Angular, a big version. It's a latest one 12 and it's a old version 8. So when we merge and you will deploy your application, there will become a conflict, because there will be application not working properly, there will be some conflicts on deployment because your environment had different version and your developers have different version. So this is the one challenge we have been facing in traditional environment. Okay, later on we realize, okay, we have to sync before merging our code, that we have a same version, and we also have installed JDK and MySQL on the all three environments same version, so that there are no more conflict when we deploy the application. So this is the second issue with the traditional environment. So let me show you the third one. Third challenge we have been facing in the traditional environment, it was when more than one developer start working with their own versions, and they started merging in CI/CD or in your parent branch, they will get conflicts. It's another issue which need to be fixed before merging their code in the main repository, so that before because it is the basic and main benefit of central repository, so that these conflict can be fixed, so that rest of application will be deployed smoothly, so the from all developers have same version. But we have to take care. Okay, again, whatever version we have approved with, let's say we have approved 12, Angular 12, then here we again have 8. So this is another issue we have to take care. Whatever versions we have agreed on the development machine, on developer 2 or on developer 1, all those same versions should be available on our deployment environment, where we are going to deploy our application. MySQL, JDK, Angular, whatever tools and technologies we are using, the version should be same. So this is, guys, third challenge we have been facing in traditional environment. So let me show you how container come into the picture and resolve all these solution and overcome all these challenges. Here, guys, let me explain and show you the challenges and issues we have fixed with the latest technology, Docker container. Okay, here you can see, first of all, we have to agree with the file. Okay, we have to mention all the versions. We are starting with development, like we have Dockerfile, where we have to mention, okay, when we start our development and start running our application, it should be automatically download and make available. Okay, we don't need to install all these version manually here, but here in traditional environment and old development methodology, we have to download, we have to make sure all the versions. If developer one version with some version, then all the rest of developers should make sure that they have to download and make available on their development environment. Most of the time, when you initiated the application and you have downloaded and it is available on your local environment, any tools and technology with the set version, might be possible after few years there would be not available link, there might be possible not available that library to download and make the possibility for the development to start. So to overcome this is the first thing we have to just mention what version and what the technologies we are going to utilize. Then we start building an image. From Dockerfile, we have command to build the image, and then we run image as a container. Okay, so here you can see its container responsibility. When we start image running as a container, it will download all the mentioned version. Similar version it should download and start working with these. Your application will be running on the mentioned version in Dockerfile. And again, another a good benefit of containerization is you don't need to make surety, okay, I'm going to run a container on a different machine and I have to make sure all those versions are available there. No, you don't need to do this, because it's container responsibility when you run your image as a container, because it is running on a Docker engine. Okay, and it is isolated from your operating system. Okay, it is not dependent, it is not relying on your operating system to ask your operating system, okay, make available all these versions, so I'm going to run and make the application available for users. But here, when you run your application, you have to make sure all these versions are available on your operating system. So here we don't need to do all this. It's container responsibility to run with all available version on Docker engine. How Docker engine operating system works, because we already have covered with the concept of virtual machine and containerization. Actually, from one machine, we virtually separated one operating system with the virtual machines. It's mean we have one operating system, but virtually we divided more than one operating system. And then actually container virtualize the operating system, not machine. So let me show you clearly in next slide. In this diagram, it is clearly defined. Let's suppose we have three containers. One is app1 and one is app2 and a third one is with app3. Every container has its own in runtime environment, right? Uh, because it is all container running on a Docker engine, container engine. And you can see we have only one operating system, one hardware. We don't need to more than one virtual machine. Like we have one hardware and we virtually divide one hardware into different operating system, then it's become virtual machine. When we virtually divide operating system into different environment, then it is called containerization. So you can see we have app1, app2, app3. At your app1 is running on Node, your app2 is running on Go, and your app3 is running on .NET. But you can see you have one hardware. Hardware mean your server, your machine, development machine, whatever you are working on, or any environment you have deployed your application. You have one operating system, either it is Windows or Linux, and just you installed Docker. This Docker engine will help you out to run more than one containers, but it's container responsibility to manage all the libraries and dependencies isolation way. App1, all the dependencies and libraries have in its own container, so it is isolated from app2. But it is very good that we have one operating system, one engine, and running more than one application, but with different libraries, different version, different. Every container have its own dependencies and libraries. So this is the concept, major concept, our containerization. It actually help us to modernize our development, and it has boosted up enhancement, performance from every aspect. We have utilized this technology nowadays. Okay, so the main points of containers are self-contained, isolated, independent, portable. Self-contained mean every container contains its own dependencies and libraries. Okay, and other aspect, isolated, yes, it is isolated. There is no any conflict, even though if you have node with in this container with a different version, it will not impact with this container already running node with different version. And it is independent, it is not dependent on even on operating system. Okay, if operating system did not have node installed, then your container will not get any problem. It will its own get the environment and start running your application. And fourth benefit is portable. You can also, if your container is running on a Linux, Ubuntu, you can also shift your container on Windows, and you can run as a you can run that image as a container on your Windows operating system. So it's containerization. It's your container responsibility to download and start with those runtime environment. You don't need to do any installation of further dependencies or libraries within that container. Okay guys, this was great video over discussion on containerization. What is container? Actually it is object of Docker concept. We have three objects like image, Dockerfile, image, and third is container. We will be discussing more in detail on Dockerfile and image in next videos. So please stay touch and be connected. Subscribe if you have not, and also press the bell icon and select all options so that you will be notifying all rest of videos. And also please share your comments if I'm missing anything and we need to improve something in a better way, then I will try my best. Due to containers isolated process, we don't know where does it get its files and configurations. How do you share those environments? That's where container images comes in. Actually, container image is a standardized package that includes all of the files, binary, libraries, and configurations to run a container. Here you can see in this image we have different layers containing different kind of material. Like at layer 4 we have source code. Whatever application we are going to work with, source code would be available on layer number 4, and layer number 3 all the dependencies. Let's suppose we have developed application in Java, all source code will be available. If you can change your source code, like in Java application, if you want to change the dot class on production, on deployment, within a var or jar you can change, go and extract all var or EA or even enterprise archive, you can extract and just replace the dot class file in source code. Okay, in traditional in methodologies we have been doing like this. And dependencies, you can also change your dependencies at layer 3. All the applications have their dependency, like if you are going to implement with Spring application, and there is any other utility that would be available here. And here you have requirements, what the projects and application is going to develop. All the requirements are available at layer number 3, where image, when we start container, actually application start reading from this layer. Okay, and here is layer number 1, which is fourth layer, right? Actually one layer. Here is runtime. For example, if you are going to deploy your Java application on that machine, you must have Java runtime. You must install JDK to make the runtime, Java runtime available to run that application. Even is that Linux, is Windows, whatever operating system you are going to use. And then this one is basis. Actually this layer contains some basic commands and our management manager, application manager, which needs to be do some basic like system level dependencies and requirements are lie on the layer number, a basic layer, which is a base layer, image layer. Okay, the another good thing is, as we have layers and we can reuse this image as I explained. What if I have this whole image available on system 1? Okay, then what? Should I have to rebuild another image, or can I use any layer from that? Yes, you can use any layer. If definitely if you want to use all the layer, you can run another container with the same image. But if you see, okay, I have source code, different dependencies might be, it is 100%. If you have different implementation, you must have different dependencies as well. But you also have the requirement as per this application. Definitely your source could have different implementation, and that might have different dependencies, and requirement also depend on all this implementation and dependencies, right? But guys, if you are going to again run the same image and application within a Java, right? Then you must have an you don't need to make available another runtime. This is the beauty of layering of this image. You don't need to layer this basic layer. You can utilize these two layers if you are going to uh, build and run another container. You can share this layer, these two layers. You can share runtime. Let's suppose if you have installed JDK 17 and you can run on that machine more than one application because you need runtime and that is available. And this is related to only your operating system. You can also share this layer as well. Layering is made possible by content addressable storage and union file systems. While this will be technical, here is how it works. After each layer downloaded and extracted into its own directory on the host file system, right? Like let's suppose it is on a host file system, extracted in different layers. When you run a container from an image, okay, if you run container from this image, a unified file system will be created, okay, here, from where layers are stacked on top of each other, creating new unified view. When you start container from this file system, okay, its root directory is set to location of this unified directory using chroot, okay. When the unified system is created, this one is created, in addition to the image layer, a directory is created. Another directory is created here, okay, on the same host, uh, for the running container. To run this container, this directory will be created. This allows the container to make the file system changes while allowing the original image, this original image layers to remain untouched. Okay, guys, got my point? This enables you to run multiple containers from the same underlying image. Within this image, if you run one container, you have seen one file system is created, then a container initiated from this, and to make this container fruitful be running in the future, a directory will be created from where this container can do some changes. If you go and run another container, the same scenarios will be happen, and this base image will be remain untouched. Okay, guys, after understanding layers of image, we will do some practical example how the base image exists, because whenever we build a new image, it becomes a base image, okay. From that onward, if you start committing and installing with that container and committing those changes within that container, it's called adding layers to that image. Let me show the example. Let's suppose we have a base image on Docker registry or Docker host. First of all, guys, you have to download and install desktop Docker, or at least Windows subscription for Linux, so that you can start working like this. So right in this session I am using Ubuntu console because in previous session we have been using VS Code. We also used Docker desktop as well. So right now I will be showing the changes, all the images container, whatever practical example I will be going with there. I will showing you on both on Ubuntu terminal and well as on Docker desktop. So let me start Docker desktop parallel. In the background it should be start, and let me uh, start with okay. First command is to get the base image, the Docker, okay, run. I'm naming it name like base container. Why base container? Because from the base image I'm going to create this one, base container. TI, what does it mean? Only I mean interactive, to interact with the console, and T mean it will get you navigate to that terminal as well. Now you are on the root of this Ubuntu operating system with Mahtab Abbasi. Once I execute the command with manage ti or dash ti, it will navigate to you on the container console. So what the name of image, base image we have already on GitHub. It will look into local machine. If it is available, downloaded already, then it will start working container, base container. Otherwise, it will first download and it will run your new container with the name of base container from Ubuntu base image. So let's start and see. Yeah, unable to find image locally, so it will start downloading. And guys, it will navigate to the terminal of Ubuntu. And once we start container, as we have discussed in previous slide, that it will be created its own directory system where we will be downloading the node.js or any other library, and then after committing, it will be adding another layer to this Ubuntu base image. Now we have downloaded new image Ubuntu, and you can see from Mahatavasi we are also navigated to terminal of this container. Here we can see we can use ls, dir, whatever we have available here. So now I will first try to update in this new terminal so that everything will be available, and there might be no use of anything else regarding to running and upgrading this container, running this image. So these are the basic commands we first start. Okay, done. Now I will install apt install node.js. Now this image, this node.js server will be downloaded on the new container directory. It will not available outside of this container, because we are in this container terminal and now it is being downloaded in this container specific to be used within this container. Okay, now I will commit this node.js to the image so that I can start working with this image Ubuntu with already installed node.js. To do this, first of all I will check okay if node is installed, and let me try to console it. Log hello max the service, sorry. Here you can see, okay, we have node installed, and we can also echo whatever we have, we can print log. And now the point of understanding, once I will commit this changes, it will add another layer to previous image downloaded with the name of Ubuntu. Okay, now let me commit this docker, sorry. Okay guys, remember that you will not be able to run docker related commands here. Remember that, because you are on terminal and you can download, install other related to terminal. If you are on Ubuntu, then all Ubuntu related commands you can execute here. If you are on Windows, then Windows related commands you can execute here. Now I will have to go to another terminal, and first I will see okay I have started new container, is it running or not. Docker ps. Okay, we have running on the port 8080. You can see here 5 minutes ago we have started this one Ubuntu as the with the name of base container. So I'm going to commit these changes because I want this node downloaded as a layer to the Ubuntu image. To do this, so that anyone else from my team if start running container, node will be available in this image Ubuntu. Anyone else don't need to install it again. But remember that this Ubuntu image will be the base image. You can start working this. It will not be it will not get change or anything else. Okay, so to do this, let me docker container commit message add node base container, and now I'm going to create new image. After committing these changes, I will be having node base. Now you have node base image with node installed, but Ubuntu with it is a base image. Anyone starting work with base image Ubuntu, no one will be having node, but starting with node base, it is Ubuntu but with node layer available, node installed. Or you can also use Ubuntu and you can also start with JDK Python instead of node, but this base image will remain same. Okay, let me show you in the example. Here you can see this base image will remain same. Okay, and actually you are going to change the runtime. You are adding layer, you have runtime installed like node.js, and I can use base image Ubuntu and I can start with JDK. I will install JDK. Base image will remain same, but the rest of layers will be changed accordingly. So now to check either I can see these changes as a layer or not, I will do load docker image history of node base. Great, here you can see, here we added the another layer into this image node base. If you will check the history of Ubuntu, you will see we also have added here. Okay, now guys, we have seen that how we can add how we can use base image and create new image with addition of some layers, and let me check, either we can use base image docker run node base node e as we printed with the Ubuntu, and now I'm going to try to check new created node base image either have installed node or not. Console.log hello max the service, sorry. Yeah, here we have again. Okay, if now we can just remove the container what we have. Let's suppose, let me check how many containers we are running now. Docker ps -a. Here you can see we must have two container, base node and base container. Okay, here is base node, sorry, node base and base container. Clear. I can remove. Okay, one thing more, guys. If your container is working and you are going to remove that one, okay, rm base container, it will ask you to stop this. If you don't want to stop and just remove with the force, you can use this one. Now you will see there is only node base. Okay, guys, same thing I can show you in the Docker desktop. But one thing about the base images, a base image is a foundation for building other images, right? You can use Ubuntu for build to start building and other images. There is no any change within Ubuntu. It is possible to use any images as a base image. You can also start with the making this base image. Okay, guys, you can share this node base and make sure that this is our node base. Whenever you start your container with any other dependency, just create another image. The command, let me show you, we have used here is, here you will write node base and here you will write new image name, and this node base will be always base for everyone, and another whatever you are going to add, commit another changes to that new image, it will remain changes. So in this example, we probably will not deploy this node base image as it doesn't actually do anything yet, but it is the base you can use for other builds. Okay, guys, so I can show you all of this. Here you can also see node base we have also available here, and I can also delete from here as well. These are the containers and these are the images we have downloaded. Ubuntu and Nodebase. In previous session we have worked with the Maxi Server demo with using OpenJDK. So we can also stop and download delete here as well. And okay, guys, so this using base image is rarely used. You will never experience, but it is very important to understand how the layers of images work and how we can add layers, more layers within an image, and how we can use base image and run container from them with the rest of the addition of dependencies or runtime, whatever layer we are going to add. And in the example you can see this is read write from this container layer, as we have seen that we have committed from this layer and new layer is added with already what we have layers within the base image, are because we can make any image as a base image and start working from that. So in next video we will be working on Dockerfile. All the commands, all the information, instruction, whatever configuration we use in the Dockerfile, I will be explaining you, and please stay touch and subscribe if you have not, and also share in your circle so that other your colleagues, your friends, all also beginners, learners can get benefits, because I'm trying my best to with important things to be highlighted, and everything I want to highlight and explain you, so that if you start learning and doing practice with Maxi service, there will be nothing to left. So that I try my best, and also please do your comments so that I can improve myself. And we know very well that the source of container is image and the source of image is Dockerfile. So we have covered and discussed in detail container and images, and today we will be discussing in detail what is Dockerfile, how to create Dockerfile, all the commands used in Dockerfile. So first of all, we have to know why we need Dockerfile. Actually, Docker can build images automatically by reading the instruction from a Dockerfile. when we run a command to build an image from a Docker file, a daemon thread, Docker ask daemon thread to read the instruction in Docker file and build an image. Okay, a Docker file is a text document that contains all the commands a user could call on the command line to assemble an image. This uh, this tutorial will guide you how to create Docker file and all the commands. I will also show you the after effects of the commands we will be using in Docker file, and I will be showing you after every command. Once I will write command and then what actually it's built after from reading the Docker file, how the image builds and available on Docker Hub as well. I will show you. So let's start using Docker file. Okay guys, just to save our time, I have created Docker file, and remember that we have using our demo project from the start, and I will keep it working on it, and whatever we will be keep learning, I will updating this and also committing these changes on the GitHub. Sorry, yeah, GitHub, and you can download and review, and you can also add your commits, you can also add your changes by creating branch. For GitHub queries and commands, we have also another tutorials available on the same channel, Maxi service. You can also go through that video as well. So it is very good to learning from the scratch within a one project, which is the with the name of demo. And I have created Docker file. You can just simply because this Docker file is created on the main folder. Just you can go and create new file. Just you will write Docker file, and that's it. It's not a matter of case sensitive. You can create with small or capital words, whatever you need. And because we already have created file and we don't need to create anyone else. So one thing more, remember that if you have already installed plugins with your IDE, either it is VS Code or other IDE, then you will be able to see this icon when you will write Docker file. You don't need to add any extension. Okay, so we don't need actually this file as we have already created. And here I have also wrote all the commands. One by one I will be uncomment and executing, and I will be showing you with the explanation of every command. So first of all, we start with the command of from, and remember that whatever or whenever we are going to create Docker file, this command should be the first command of your Docker file. Okay, uh, and also you can also have multiple uh, from command as well. Whenever you have from and subsequent commands, and then you can also again add from command. Okay, so Docker daemon thread will execute from the sorry, top to bottom all the instruction one by one. So let's start with the working with the first command, which is from. And this command actually build your image from the base image. Definitely whenever you are going to build an image, there must be an base image. Let's suppose if you are going to execute your utility or software or any application, you must specify, okay, I am going to create this further image, but my base image will be Ubuntu, or my base image will be JDK, OpenJDK 17. Even you can also use Python. If you are working on Python, then you have to mention here your base image as a uh, Python library. Otherwise, if you are working on Java based project, then you have to mention that okay, from JDK 17 onwards, my source code will be working. If we will not mention JDK as a base image, our application will not work as expected. Okay, if nothing I do anything else, then I just only I can build my image with the from command as well. You don't need to do any commands. So every command have its own purpose. So let me show you how to build the image from this only single command. We will also adding a terminal. Okay. Okay, I have to stop. Okay, because it's not allowing to execute shell script, so that's why I have stopped this. Okay. Okay, simply I will first, as we have covered two approaches, create image, build image from Dockerfile. Also, the other way we have covered uh, the way from just to run commands like this, Docker build demo latest. We can also use anyone. So first of all, we will be looking for any images exist. Okay, guys, because we are on this main folder. First of all, we have to move into demo. Okay. Okay. Another thing, because I'm not running Docker desktop, because Docker engine is not working, so that's why I'm not able to execute any command. So in this case, if you get such kind of error, then you have to run your Docker first. Okay, now I will try again. Here you can see we have lot of images already available, and we have to delete all these images before moving forward to avoid confusion, because if we have already lot of images, then it will create some confusion. So let me delete all of these first. We go into Docker Hub and delete. First I have to check how many containers I am running. So let me try if I can delete already running containers. We can also do these with the commands. Just to save time, I'm going to delete all the images. Okay. We don't want to waste time because I have to check why I cannot delete these images. I can also try to remove volume if these are linked with, if there is any build Docker Hub. Okay, guys. So first of all, I have to let me check it again. So there are now a few images left. I will work on it separately and delete these. So I want to create image from JDK 17. So let me execute the command. How this name is happening, because we have added settings. Here you can see Here is the image prefix and here is artifact. Artifact is the demo and prefix is makes the service. And where is that? Here is. Here is image prefix and here is artifact. Artifact demo. Okay. So now images being generated and then we will be able to view these images available here as well. So definitely it takes some time. Okay guys, we have created image demo with the from JDK as a base image and the next command is maintainer. Why this command is used, let me show you. Maintainer actually is deprecated and we can use instead of maintainer we can use label and let's suppose we can use author is makes the service. So when we will inspect this image, it will show us in the inspection. Let's suppose if you want to view who is author of this image, you can inspect image and it will show you the name of Maxi service. So we will be covering when image will built and I will show you. So instead of because my concern is to just save time and I'm moving to the next command which is run. Actually it specifies the it execute command in the container. Okay, when you run a container and you want some commands to be executed, as you see that first we have image, then we have container. Now we are building image and when we run image as a container, these commands will get execute. Okay, so let me add some examples to show you, like if I want to execute command, what we can just add echo. Let's suppose if I want to add echo, what I want to echo. Let's suppose I want to echo sorry, any environment variable like home. I can echo what is home of this container if I have already added home variable already set it. So it will print home. I can also echo uh, welcome to the Max the service YouTube channel. Whatever command we can execute under this uh, shell. Eh, Okay, so next it's CMD. Okay, CMD. What this command actually do? It specifies the default command to run when the container starts. If you want to run a command when container starts, then this is also helpful. So for examples, we you can also use a CMD like echo and hello maxi service. Okay. Uh, Actually what the difference of CMD and run is, I will also explain when we will doing some example. uh, you can also use a CMD like same as I have showed you with the printing home variable, any other variable. You can also do this. I mean you can also run any command using CMD as well. Okay, next command is expose. Okay, expose. This is very important command if you want to building an image which will be running as a container and serving as a application. So let's suppose if you want to expose your port of your application. Now I'm working on a project demo, and when I will run this demo as a container, and I will be accessing this demo project with some specified port. It will be available default port which is 8080. I can also use any other than 80. Let's suppose I'm going to run with 8081. So through this port, because I'm going to expose by myself. Okay, if I want to expose this port other than, let's suppose, whatever, I will be able only to access with this port. But remember, what port you are specifying, it will be with the range of given, like either your application support that port or not. Okay, next command is env. If you want to specify your environment variable, okay, then you can also use env. Okay, let me add an example of env, uh, like, let's suppose, please give me a second. Let's suppose if you want to set, okay, you can also use same as label, and you can also set your Java home, your Tomcat application server variable home. You can also set any other key value pair. So let me give me a second so I can show you proper with example. Env, where is en? Yeah, let's suppose you want to set your Java home, then you can just simply add Java home this, and you can also execute this command again. It must print like Java home. Okay, Java home. Okay, let me delete this one. So we will be checking how run works and how cmd works. And next command is, guys, add. What actually add? It copies files from the host to the container. Okay, when we will use command add, it copies whatever we want to add from. Let's suppose if I want to add my source folder and destination is demo, it will copies this source folder into demo folder. Most of the time we use source, copy source into source. Okay, and then next command is copy. So this is this serve as a same. We want to copy source to source. Okay. The difference is uh, one command is used to copy from remote. If source is remote, then we will use add. Okay, actually use add for remote resources and archives. If you have, let's suppose, not on the local machine and you want to copy from the remote, then you will use add. Otherwise, you will be using copy. So because we are using the same machine, so we will be using copy. Okay, here let me copy the commands. Yeah, here you can see we can use both, but because we are working with the same machine, we will be using copy. So copy, actually it will copy build whatever jar we have here, okay, into demo.jar. It will rename and with the current directory it will build a demo.jar. Okay. Okay, next is our next command is entry point. So what does it mean? Actually, entry points specifies the entry point of the container. Got my point? I mean, when container starts, where is the entry point? It will the start and execute the command given in this entry point. Okay, it will start Java application and with the manage dot jar command, because we already have copied demo.jar, and then it will start executing demo.jar, nothing else. Okay, so next command is volume. Guys, I think we have to build an image with this and see either we are able to accessing this application with 8081, are we getting echo this, and also we are getting this Java home. So we'll be covering one command one by one. So first let me start with this. So let me start building this. Okay, failed to solve, build failed to solve, match metadata, Docker, latest, access denied. Okay, may require authorization, server image, insufficient authorization. Okay, then I have to use this one. Okay, okay, let's see either if we have available image on the host Docker Hub. Yes, we have available, and there is no any container, and you know the command how to run the container. Here I am going to running container with this 8081, internal is 80 demo. Let me start this. Okay, so demo application is running, and let me test either we are able to access it or not. Localhost 101. Okay, white. Hello. I have to check either my container is working. Yes, our container is working, and if I 001, oh sorry, yeah, hello demo. So we are able to access this application with this, and we have successfully executed all these commands. And let me show you, we let me inspect the image and show you the author name and other commands either run successfully or not. So here will be inspect. Let me find author. Here you can see we have labels authors and Java home, cmd echo Java home, and we have copies demo.jar as well, and our docker daemon thread execute this demo.jar, which is available and running now. And what other thing I can show you? Okay, okay guys, I have showed you everything. Where here you can see authors, and the host port is 8080. Here this one is internal port, and expose port is 881. And let's start with the next command, volume. So what is volume? Can we check Java home? Yeah, here is. You can see environment variable already set at Java home as well. And also let me show you latest, and mhm, wait. View container usage, pull, push. Okay. So let's start with the next command, which is, let me stop this one and delete this one so that we will be able to run from the scratch. Okay, you can see here are two volumes attached with the other application, and we will be able to see another volume with this image when we will write volume command. Okay guys, we have executed many commands in Docker files, and we have also reviewed, and I have also shown you when container runs, and if we go for inspection, then you can see, let's suppose if I'm going to run this image, and now here a container must be available, and I can show you in inspect that you can see your cmd echo Java home. You can also execute this command and see your Java home, like uh, uh, Java home. You can see here, you can also view your already set parameter environment variable, and you can also inspect and see if you have also set env Java home. Here you can see as well. Here is, and you can also see your labels, whatever label we have already set. The author is maxi service, and everything we can set and verify in the inspection. So next command, volume. Here you can see we don't have set any volume, and you can also see your files here, and you can also set your volume under dev anywhere else. So let me go into the Docker file and add volume. Well, let's suppose I'm going to set volume here. Actually, volume instructs creates a mount point with the specified name and marks it as holding externally mounted volumes from native host or other containers. Let's suppose you can set this volume as a external storage. You should use volume instructs to expose any database storage area, configuration storage, or files and folders created by your Docker container. You are strongly encouraged to use volume for any combination of mutable or user serviceable parts of your image. Actually, some constraints, notable things about creating volume. If your container is working on Windows, then a non-existing or empty directory. When using Windows-based containers, the destination of a volume inside the container must be one of non-extension or empty directory, and drive other than C. You can set your volume. This is just to specify precautions when you setting volume, and changing the volume from within the Docker file. You must consider if any kind if build steps change the data within the volume after it has been declared. Those changes will be discarded when using the legacy builder. When using like a build kit, the changes will instead be kept. You can also using JSON formatting, but take care list of parsed as a JSON array. You must enclose words with double quotes. Never use single quotes. So these are the some tricks, and you must be consider when creating volume. So let's suppose I have set it volume, and in running container I have shown you the there is not available volume here. Okay, is it's a null, and let me execute the commands again and see build. Let me refresh. Sorry, I have to stop or delete this container, and now I have refreshed images. Okay, and I believe if I run this image, it must have a volume available. No, still we don't have volume, and let me verify it again. Let me delete this image as well. Actually, you can see it's 44 minutes ago, and let me see. Okay, there is change with volume, and let me build it again and run container. Let's see. Inspect volume. Here you can see we have already added data under this folder. Whatever your container will create any data for and use storage this data folder, not other than this. So next command is, guys, what is user command. Actually specifies the user to run the container. As if you use user, it instruct user instruction sets the username or UID, user ID to use when running the image, and any run CMD entry point instruction that follow it in the Docker file. So to execute a user, let me also share example with you. Okay, next command is user user command. What actually user command does, user instruction sets the username and optionally the user group to use a default user and a group for the remainder of the current stage. The specified user is used for running instruction, like if you are this user will be able to set entry point, run some command, can run some CMD commands as well. But note that when specifying a group of the user will have only specified group membership. Any other configured group memberships will be ignored. So let's suppose if you are using Windows and you want to create a new user like Maxi service, then because you have to first create user, and here is good thing that I am again using from command, and because I'm going to create user from micro Microsoft uh, Windows Windows Server Core. Okay, Microsoft Windows Server Core, and here I will execute run command to execute this user, which is net user and slash add maxi service. Okay, maxi service user will be used to run any command, can use entry point to also can run some CMD or any other command this user can run. So just I have to confirm that this one, actually it is soft MICROS Microsoft Core. Okay, so let's see either we are able to run this. Can we create this user from Microsoft Windows Server Core or not? So let me stop this, and also for your uh, understanding, I have to delete this container to avoid confusion. I am also going to delete these images as well. So let me build an image this with this new user. Okay, so this is creating problem, failed to resolve. This is a failed to resolve, use source metadata docker io pull access denied, repository does not exist, and then okay. mm, Microsoft Windows, let me use this one then. No, pull access denied because this repository not allowing me to pull this user because I'm using this as a base image. Definitely when I will create new user from this base image, it is not allowing me to create user. It is not allowing us because now I will be using uh, Linux environment because as we are working with WSL and 2 and we our Docker host is running on uh, Linux environment, and I will be using Ubuntu latest. Okay, and the command I will be using apt get -y update, and again I will run command group add -r user and user add -r group user, and I'm using user. Now let's try again. You can see here pulling Ubuntu latest and to create user. So it will take some time to create user, and now we can see image should be available here. You can see 9 seconds ago, and let me run this as a Docker container and see here it is running. Okay, and now the new user is available. uh, Let me check if I we can see from here. Here you can see config. So in configuration we have created user. So this user or create a new one can execute any command once log into this container. So I will show you how this user can execute all these commands later on, because we have short time and we have to complete all the commands. So next command is uh, working directory. Work directory. So what is our working directory? What the purpose of this working directory is? It actually sets the working directory for any run, cmd, entry point, copy and add instruction that follow it. Let's suppose if right now we are our working directory is demo. Okay, uh, other than other than demo, if you will go back, let's suppose in maxi service, and you will run some maven clean install, it will create problem because our working directory is demo. So we have to move him to demo, and then we can run clean maven clean install. It will work fine because we are on the right working directory. So we must define our working directory when we start working with the Dockerfile. So our working directory, let me show you. I already have copied. Yeah, you can see our working directory is demo. So we will be using demo. Demo, yeah. This is the only simple. You can also add slash as well if you want to. Okay, next command is uh, it's mean whenever I will execute any command. Let me elaborate little bit more. Let's suppose if I'm here and I want to execute any command, then my working directory will be demo, not any other than that. Argument. Okay, arg. ARG actually used to define a built-in build time argument. Let's suppose if you are going to provide during build time your image, if your image is going to build and you want to pass some argument runtime, okay, then you can use this instruction argument. Okay, actually, argument defines a variable, like you can use user and provide some value like maxi service, and uh, it will user key must be provide value maxi service as a runtime. And you can also but you can also use multiple variables defined, like one argument user, second argument is build version, let's say it's a 1.1, whatever version 1.1, whatever you can provide at runtime, because you can read these values runtime from different uh, environment. Like if you have a dev environment, production, Q environment, you can also read different values from different environment variable. So one thing we need to know, it is not recommended to use build time variable like if we are passing, let's suppose credentials. Okay, credentials like ABC 1 2 3, whatever is, you don't you cannot use this argument to pass like GitHub keys, user credentials, etc. build time, because this can be seen with the using of Docker history command. When you anyone access on your container and can run Docker history, um, it it will be shown to that user, and your secrets will be exposed. Actually, environment variables define using env. Let's suppose if already you have defined like env here, this one, and again you are also providing, let's suppose I have provided env Java home, and again I am going to provide argument Java home with different, let's suppose D, it will override. Now your environment variable will not be available longer. This will be override with this new value, whatever you will add. New value added will be override env. Okay, so take care when you are going to provide argument, take care to provide mentioning the key that will not be available before that argument. Actually, Docker has a set of predefined defined arguments as well, like if you want to provide HTTP proxy, ठीक है, proxy, or you can also add FTP proxy, no proxy, whatever. These are some predefined uh, uh, argument. Okay, so uh, argument it can be passed at runtime, and let me show you. I have added some argument like user, because we don't have already provided user key, and there was a build version. argument build version 1.1. So it you can also provide like this. So if I run build and again run container, then I can also view these values as well. Okay, let's see what is on build command. On build command actually run instruction when your base image going to start build. Let's suppose you are uh, you are building this image, and whenever anyone else will be using this demo as a base image, then these instruction will be running. Let's suppose you want that, okay, whenever uh, this demo uh, image will be base image, and someone else going to create from demo 2 or any other image, then I want to copy docker file into data folder. Okay, then actually this is um, a source and this is destination. Okay, whenever you want some instruction to be executed, then you have to, let's suppose you want to copy and docker file into data. Whenever anyone within your team or anyone will use this demo image as a base image and create another image, let's suppose if someone is going to use from demo latest, okay, whenever anyone will be using this as a demo image as a base image, then before building this another image, whatever you name it, it will start copying this docker file to data folder. So this is actually the purpose of on build adds to the image a trigger instruction to be executed at later time when the image is used as a base image for another child, for another build, the trigger will be executed. Any build instruction can be triggered as a trigger. Okay, guys, let me show you because we have used orgs, and if I go to use Docker history demo, you can see here all the argument you have created. That's why whatever you have configured, you can see everything. So that's why it is prohibited to use argument for secret information, so that anyone else will not be able to view and misuse. Okay, guys, I am leaving three commands. One is stop signals. Uh, you can use sig kill, sig term, whatever, and the second is health check, okay, and the sorry third is shell. I am leaving these three instruction Docker file commands for you to have some practice and share your knowledge, share your experience in this video. So if you have any issue with these commands, I will explain in the next video. Otherwise, I hope you will be able to execute and utilize in Dockerfile. Just I'm not going to work with these because I want you to do some practice and see what happened with all these instruction. So everything is in this file, and I will commit these changes into GitHub, so you can uh, uh, utilize directory repository on the GitHub. You can download and create another branch and start working with it, because we will be continuing with this demo project. Whatever we will be learning, we will be adding into this. So next video will be Docker objects, combination of this video and last two previous video, like container, image, and this one. So please keep in touch and subscribe if you have not, and also don't forget to share in your circle, and please like my video and share your experience, share your some comments, so that I can understand what actually I'm going to miss, or where I can improve. So thank you. Bye. Okay, please subscribe my channel if you have not subscribed yet, and also do like, share in your circle these videos, and also provide your valuable comments. And I hope you will be liking and sharing, so that I will be continuing with rest of the technologies and tools sharing with you. Thanks.